In this module, and in fact in this module and the next two, we're going to be talking about machine learning. And machine learning is a very general concept that covers a lot of parts of data science, with a particular focus on prediction and on clustering. And here we're going to look at two specific problems that machine learning is very well equipped to handle. So first of all, the problem of classification, as in predicting which group an observation is going to fall into. For example, the example that we're going to use in this module and the next is about accessory dwelling units. Can we predict whether or not a parcel of land is going to have an accessory dwelling unit built on it? And then the other aspect of machine learning that we will focus on is clustering, and that's going to be in 2 modules' time. So in this lecture, we're going to start by talking a little bit about the general principles and concepts in machine learning. And then we're going to really review some of the data wrangling and push that a little bit further in order to generate a data set that we can set up and then do some machine learning on. So this lecture here is going to be much more about data wrangling, so we get into a position where we can actually do some machine learning in the next lecture. So as a broad generalization, classification in machine learning is often focused on prediction. And you can see some examples linked from the notebook in your GitHub repository. And these are on the readings tabs as well. For example, which neighborhoods are most likely to gentrify? We can perhaps understand urban gentrification through machine learning, predict which neighborhoods are going to fall into gentrified or not gentrified categories. Another reading on the list is predicting which facilities are likely to be violating environmental standards. That could be a very useful tool for environmental enforcement agents. Or some of my own work predicting the race and gender of an author on a course reading list. For example, if you're trying to ensure that the reading list for a course is more diverse in terms of the background of the authors. There's also some applications which often deservedly machine learning gets a bad press from an ethical point of view or a justice point of view. Predictive policing is one case in point. And we're going to come back to these issues in a few weeks when we talk more broadly about policy and ethics for data science. But there's a link to one good article on this in MIT Technology Review if you want to read a little more at this stage. What machine learning doesn't do so well is questions of causation and hypothesis testing. Perhaps a domain of statistics and causal inference methods. Machine learning is looking for patterns in the data. It doesn't know what's a cause of what. It's really looking at associations. But there's a lot of overlap between statistics and machine learning, given that much of statistics is also really about associations, even though it's sometimes inappropriately dressed up in causal language. So the classification that we'll look at in this module and the next consists often of 3 widely used approaches. So there's logistic regression, which you might be familiar from a stats course, but it's a starting point for much machine learning analysis. And it's also a benchmark. See how much better some purer or more advanced machine learning methods can go beyond what you get with a more traditional logistic regression model. This module and next will focus on random forests, which were one of the most powerful and commonly used machine learning predictive classification techniques. And then we'll also touch on neural networks, which is often used for image recognition, but can also be used for these types of classification problems. And we'll see actually once we do one of these, once we set up the data and the code to be able to estimate a random forest model, it's actually really easy to do a neural network or another type of machine learning analysis. The principles and the syntax is very similar across all of these types of models. So once you know one, it's pretty easy to pick up another technique. Another thing I'd like to emphasize at this stage is that machine learning is a really big field. You could take whole courses or sequence of courses on machine learning, particularly if you want to delve into the theory. And here we're going to give a really high-level overview. I'm not going to go much into the theoretical underpinnings of some of these machine learning algorithms. We're going to be focused on how to implement them to a real-world data set in Python. And the example we'll use in this lecture and the next few is accessory dwelling units in Los Angeles. So the problem here is, can we predict which properties are most likely to construct an accessory dwelling unit, an in-law unit, it's sometimes called, or a backyard unit, sometimes a garage conversion. And you can imagine that this type of analysis could be useful to planners and policymakers trying to figure out where population and housing stock increases are most likely to come through this type of infill housing development. So we're going to obtain the data from the city's building permits database. This gives us an indication of whether or not an ADU is built on a parcel. And we're going to link it to the county assessor parcel database. And this provides some other information on each lot, like the lot size, the assessed value, and so on. So because both of these data sets are very large, I did some pre-processing and saved a slimmed-down version in your GitHub repository. I extracted just a few fields and limited the building permits to those that included an ADU and threw away the rest, and limited them in the city of Los Angeles. And this is really so we have a manageable size data set to work with. So we have two input data files, permits and parcels. As always, follow along with the code in this notebook, which is in your GitHub repository. So we're going to add a column to this data set of parcels. So we have one observation for each parcel. It has a value true if an ADU has been permitted on that parcel and perhaps built, and false otherwise. So we can do a little work. Again, this whole lecture is about data wrangling. There's some work to do in joining the data sets together. And if you're interested, this code here, this is just what I use to read in and save a subset of a database. This if zero syntax is a nice shortcut to basically saying don't execute this block of code because if zero is always false. So this never gets executed unless I just want to do it. Then I change it to if one, which is always true. So we'll just read in the file that I created for you and saved in your GitHub folder. And let's look at the first 5 rows. So we see they have 3 columns that identify the parcel, the book, the page, the parcel number, and this is standard terminology for assessor recorders, and then the number of accessory dwelling units on this parcel. Most of them are 1. There's a few that have more than 1. And then we'll do the same for the parcels data set, which is huge for LA County, and so this code again, I executed this for you. I just selected a subset of the columns that might be interesting, dropped the remainder, and saved it to a CSV file. So let's read that into the data frame, or a geodata frame called, it's a data frame right now, it's just a CSV, but it's parcels. So we can see that we have the assessor parcel number, use type, and some potentially interesting and useful fields. And then we have the latitude and longitude, the spatial data for the center of that parcel. So how can we join these together? Well, if you look back at the parcels data frame, we see that we have this APN field, which looks like it's a concatenation of 3 different fields that we see in the permits data frame: assessor book, assessor page, assessor parcel, which are represented as 3 different columns here. So if we want to join these data sets together, we have to kind of create something from these 3 that looks like this. Or we could go the other way, right? We could create 3 different columns from this APN. So first of all, we need to create each column to an integer. Otherwise, we have a string that has a decimal point and a 0 after it. Remember, we had that problem in a previous lecture. Then we'll convert it to a string. Then we'll pad with zeros. And then we'll concatenate the columns and separate them by this, by this hyphen. So we've done this first 3 before. in a previous example, and now this is the extra step that we're going to take this time. So we're going to do it in one step. We'll create this accessor book column. We'll convert it to an integer to drop the decimal point in the 0. Then we'll convert it to a string. Then we'll pad this out with a leading 0, so it's 4 digits. We'll add a hyphen, and then we'll do something similar for the assessor page and the assessor parcel columns. So let's try this. OK, we get an error. So let's see what that tells us. So it's telling us there's an invalid literal for int with base 10 star star star. What does that mean? Well, it means that this int function is receiving some input that is not valid. And if we look at this, we can guess what the problem. Star 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 can't be converted to an integer. And so this error is being called by the permits assessor parcel as type int part of the code. There are probably some values here which are star 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 and can't be converted to an integer. So let's look at these rows. OK, we see what the problem is. It's not clear what's going on here, but let's just drop them. That's the easiest way. And we can do this with this not equal to, this exclamation mark equals operator. So in this line here, we're saying have true for all the permits where the assessor parcel is not equal to star star star. And so for these rows that are true, we use it to create a subset of this permits data frame, and then we'll put it back in permits. So we'll overwrite what we had before. So let's try and do this again. OK, that looks much more reasonable. And so we have an APN field that looks pretty similar to what we had in the parcels data frame. So let's try and join them. Now, pause the video here and think, what's your strategy here? In particular, what type of join do we want? Look back at the types of joins we saw in the last module. Do we want a left join? Do we want a right join? Is it going to be an outer join, inner, one-to-one, one-to-many? How are you going to join these two together? Sketch it out on a piece of paper, and then if you want, try and write some code. So there's two things that we should consider here. First of all, we need to keep all of these parcels, even if there isn't a corresponding permit. Remember, a permit data frame only has observations where there is at least one ADU. We actually want to keep in our data set parcels that don't have an ADU rather. We can't do any prediction if we only see the positive examples. We need to try and distinguish between the negative that don't have an ADU and the positive that do have an ADU. So that implies that we're doing a left join to the parcels data frame. Right? We want to keep every single parcel, whether or not it's joined to a permit. And also, we don't want to duplicate parcels. So we should actually duplicate any parcels that have more than one observation. So let's first see if there's any duplicates using the isUnique on the APN field. So it's not unique, so we do have some duplicates in both the permits and the parcels data frame. Pandas has a convenient drop duplicates function that is simple to use. We can also use group by, because even though we've seen group by to do means or counts and so on, there's also a function that takes the first observation in each group. So if we're not really worried about which one we take, if there's a lot of these duplicates, we might care more about aggregating these. But if it's just a few, as I suspect it is, something we can verify, we can just make it simple for ourselves. And a nice byproduct of using group by on the APA column is it promotes APM to our index, and then that's going to make the join easiest. So let's look and see how many we have before. Let's group by, and rather than a count or sum, we take the first. Let's look at the length afterwards, and then let's check that the index, which is now APN, is unique. So we drop about 1,000 permits from this data frame. We could do some aggregation, but let's keep it simple for now. And let's do the same So we have our APN as the index now. And let's do the same for the parcels. And we drop just 2 parcels. Okay, so in this analysis of this scale, that's not something that I'm going to worry about, what's causing that. And we also have now APN as the index, so we can now proceed with our join. So pause the video here, see if you can figure out the join for yourselves. Remember, we're doing a left join, which is a default, so we don't actually have to specify this, but we can for clarity. So we'll do a left join, so keep every parcel and join it to the permits, and the default is the index, so we don't have to worry about specifying a column. And we'll create this new data frame called join data frame. And let's just look at some counts. So we started off with 790,000 parcels, and this is just a count of the number that actually have something in this accessory dwelling units field. This isn't including the nulls that didn't produce anything in the left join. So this is roughly the same number of permits we had before, so that's good. And so we can see that if they didn't join, then these are going to be null. But there's 25,161 that aren't null in this final column. So this all seems good, but we probably want to create a column that is 0 if this is null, so there's no ADU because it didn't join, and 1 otherwise. So here let's use our lambda function again. So we saw that in the previous module. It's a little counterintuitive, so practice is good. So what are we doing? We're creating a new column that is just going to be true or false. Does it have an ADU? And it's going to take the value in this accessory dwelling units column, and it's going to apply this lambda function. So the value of this column is going to reappear inside the anonymous function as x. And then we're going to return false if x is null. Otherwise, we're going to return true. So let's have a look. And so these ones that were false before, these were null before. Now we've created this new column that is false. So there's a lambda function. Pause the video, see if you can rewrite this a different way using a regular function rather than a lambda, and verify that you get exactly the same result. Okay, how can we do this? Well, let's define a function that takes an argument that we're going to call the number of ADUs, n ADUs. And if this is null, then we're going to return false. Otherwise, if it isn't a null value, we're going to return true. And so let's create this as a new column that has ADU2, just to distinguish it from our previous has ADU column. And that's going to take what's in here and apply, and rather than applying a lambda function, we're going to apply this function that we defined here that was called hasADU. So again, the value for each row that's in this column is going to reappear inside the function as this nADUs variable. So let's run that, and then let's just verify that these two are the same. So for all these rows that we see here, the first 5 and the last 5, these are all the same. We can also use the numpy all function to verify that for every row in this array, these two are the same. And that's correct. So let's just drop this temporary column that we use just to check our results. So let's stop there for now. We're done with most of our data wrangling. So now we're ready to proceed to some machine learning. So let's save this data as a pickle file. This is a pandas object or a native Python object. And this is really good if you want to save something temporarily. Again, it's not advisable for long-time archiving or sharing your work because the formats can change. So we're going to take this data frame and store it in your repository in what I created as blank Scratch folder for you. And then this will be available for us at the start of the next lecture. So the takeaways I'd like to leave you here. We talked quite a bit about the principles of machine learning. And machine learning is really valuable for prediction, and it's even more valuable for prediction compared to, say, regression, when you have a lot of highly correlated variables, and you can't really separate out which ones are driving your prediction. We'll see an example of this in a couple of lectures' time. As any task in data science, data wrangling is going to take up a lot of your time. It's always your first step, and these types of joins are going to come with practice.